Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. A particle moves along a line according to the law S of t equals 2t cubed minus 9t squared plus 12t minus 4, where t is greater than or equal to 0. At what time the particle changes direction? Find the total distance traveled by the particle in the first 4 seconds. Find the particle's acceleration each time the velocity is 0. The way we go about solving this particular problem is, we've been given the equation. So let's write down what that equation is. And the answer for all the three questions basically stems from this particular equation, right? So let's write that down first. And let's analyze this, right? My t, of course, being time, is always greater than or equal to 0. So at the moment the particle starts off, which is when t equals 0, right? I notice that my particle is not at the origin, right? Why is that? Because my s of 0, which is where the particle is stationed, okay, at time t equals 0, is given by this equation with the substitution t equals 0. So what I will end up is minus 4, right? So let's call it units, right? We've not been given whether it's feet or meters or whatever it is, so we will just call it units. So the way I need to visualize this, right, and in case you want to represent this diagrammatically, and it becomes important especially for the second part of the question. So remember that the particle is moving along a line, and let's draw a line like this. I know that this line is not straight, and let's call this as the origin, right? And at t equals 0, your particle is actually here, right? This is minus 4 units, right? And if I can, let me come back to the problem. So we've been asked to find at what time the particle changes direction, right? So the way we understand this is, okay, the particle starts from the point x equals minus 4, and I'm just calling it as x, right? And it moves in a particular direction, right? And then it changes direction, right? If we are to go by question 1, and then probably it changes direction again and keeps changing direction as it moves through this particular line, right? Because otherwise you will not have this question 1, at what times the particle changes direction. So the first thing that we will have to figure out is the answer to question 1, which is also going to tell us is the particle changing direction as it moves from minus 4, right? From the point minus 4, which is where it is stationed when t equals 0. And how do we find that out? What happens when your particle changes direction? Your ds by dt, which is your rate of change of distance, changes sign, right? And what is that? Your ds by dt, which is nothing but your velocity, is going to change sign, right? So let's assume that your ds by dt equals v, and I have my s, right? So my s is 2t cubed minus 9t squared plus 12t minus 4. So if I differentiate it on either side, I get ds by dt equals 6t squared minus 18t plus 12, right? I know that I can pull out the 6 because that seems to be like a common factor for the entire uh, equation. And I have my t squared minus 3t plus 2, right? And I know that I can further factorize this. T squared minus 3t plus 2 equals 6 times t minus 1 into t minus 2, right? I hope you folks are with me. So now I can see that the velocity is not always positive, Why is that? Because my v, when I express v in terms of t, I have 6 times t minus 1 into t minus 2. So I need to figure out when does the particle change direction to answer my question 1, right? Now let's look at this. Let's break this into three parts, right? So I start off from t equals 0, and which means that 0 less than or equal to t less than 1. What is my v? My v is going to be given by the equation 6 times t minus 1 into t minus 2 is going to be positive, right? Why is that? Because your t minus 1 is negative, your t minus 2 is also negative. So which means your t minus 1 times t minus 2 is going to be positive, right? Now let's come to t equals 1, right? At t equals 1, you're going to have your v becoming 0, right? That's point number 2 that you'll have to keep in mind. And similarly, I'm going to add it here at t equals 2 as well. Your v becomes equal to 0, right? So at t equals 1 and 2 seconds, your v becomes equal to 0. And now what we have is 1 lesser than t lesser than 2, right? What happens here in this interval is your t minus 1 is going to be positive and your t minus 2 is going to be negative. So what happens is your v is going to be negative, right? So now I think you have the answer for question 1, because you see that when the particle starts off at t equals 0, the velocity is a positive number, right? And in fact, you can substitute t equals 0 to see what is the particle's velocity, instantaneous velocity. You will see that you will get a 6 times minus 1 into minus 2 because your t equals 0, which means that your velocity is 12. And the particle continues traveling with a positive velocity until t lesser than 1, and at t equals 1 it stops, right? And then in the interval 1 less than t less than 2, it changes its direction, and which is why you have v equals negative. And then it comes to t equals 2, and again your particle stops, right? Now let's come to the last part of this. What happens when t greater than 2, right? So when t greater than 2, my velocity is quite evident that it's positive, right? So, and then I don't think beyond that you need to worry about if there is a change in direction, because t greater than 2, your velocity is always positive. So what we see is it starts off with a positive velocity, 0 less than t less than 1. At t equals 1, it stops, which means it becomes a 0. At t greater than 1 lesser than 2, it is negative, which means it has changed direction at t equals 1. And then at t equals 2, it again stops, which means that your v equals 0. And at t greater than 2, your velocity changes from negative to positive through 0, right? So now I know I have the answer for my first question, which is at what times the particle changes direction. So I know that t equals 1 and t equals 2 seconds are the two instances where the particle changes direction, right? Because there the particle stops, and before that and after that, I see that the velocity changes from positive to negative or negative to positive, which is why we have the answer as 1 and 2 in this case, right? Now let's come to the second part of the question, which is where I want you folks to think a lot more than what the first question demands. Find the total distance traveled by the particle in the first 4 seconds, right? Now a lot of us will tend to directly make a substitution t equals 4 and arrive at an answer, right? But that's not the right approach for this problem, especially looking at the polynomial that defines your s, right? in this particular problem. So what we understand from part 1 is that the particle starts off from -4, and then let's say call it t equals 0. I'm going to use my drop in again, and I want to understand at t equals 1 where is the particle actually located, right? And how do we do that? Let's use s of t equation to calculate where the particle is at s of 1, and later we will come to s of 2, right? So I'm going to start with s of 1 because from 0 to 1 it just moves in one direction, right? So my s of 1 is nothing but 2 minus 9 plus 12 minus 4. It's just a simple substitution, t equals 1, and what is that? Which is nothing but your plus 1, right? So what I see, the particle at t equals 0 is at -4, and let me use my pen here. Okay, and at t equals 1 it has come to your point. -4 is at t equals 0, and at t equals 1 it is at 1. So what happens is between t equals 0 and t equals 1 we have traveled a distance of -4 mod of -4 plus mod of 1, which is 5, right? 5 units is what is being traveled. And the reason we are forced to break this and not apply the equation directly is we know that the particle changes direction, right? So I need to figure out now between t equals 1 and t equals 2 how much the particle has traveled, right? So for that, all that I need to do is figure out where the particle is at t equals 2, right? So again, it calls for substitution of t equals 2 in the above equation. So I get 2 times 2 cube, which is 8, minus 9 times 2 square, which is a 4, plus 12 times 2, which is a 2, and then minus of 4. So let's see, what do we get? 16 minus 36 plus 24 minus 4. Minus 20 plus 24 minus 4, which is nothing but a 0, right? So I know that the particle changed direction at t equals 1, and let me use a different color now. Say let me use, say, a green color, right? Now at t equals 1 I see that my particle reverses direction, and at t equals 2 it comes to the point 0, which is nothing but the origin, right? So what is the distance traveled between 1 and 2? I mean, t equals 1 and 2, it's 1 unit, right? So I know that S of 1, we were at 1. S of 2, we are at 0. And during this interval, the velocity is negative, which is where diagrammatically, when I represent it, the particle moves in the reverse direction, right? So basically, the distance traveled between 0 to 1 is 5 units. Between 1 to 2 is 1 unit, right? So the total distance traveled from 0 to 2 is 5 plus 1, which is 6 units, right? Now the question that have been asked is find the total distance traveled by the particle in the first 4 seconds, right? So we now know what the total distance traveled by the particle in the first 2 seconds, right? Now, do I really have to worry about it at greater than 2? The answer is no. Why? Because t greater than 2, the velocity is always positive, right? As given by the equation 6 times t minus 1 times t minus 2, right? I'm referring to this particular equation, which we arrived at through differentiation, and let me highlight it in yellow color. So this is always going to be positive when your t is greater than 2. So I really do not have to worry Okay, so now all that I need to do is when S of 4, where are we? Right? S of 2, we are in the origin. S of 4, where are we? Again, I go for a substitution. 2 times 4 cube, which is 64, minus 9 times 4 square, which is 16, plus 12 times 4, minus 4. And what does that give me? 128 minus 144 plus 48 minus 4, which is nothing but 28, right? So between S of 2 and S of 4, when I moved from 0 to 28 in one direction, right? So let's go back to the diagram. I'm going to go back and use my orange color now. So when I use my orange color, this time what I have done is I've gone from 0 till 28, and let me call this 28. And folks, this diagram is pretty shabby. I'm not really an expert when it comes to sketching on Word, and this diagram is not to scale, right? So what is the total distance traveled from t equals 2 to t equals 4? So we have traveled a distance of 28, right? So the particle started off from minus 4, traveled a distance of 5 units, and then changed direction, traveled a distance of 1 unit, comes back to the origin, and again changes direction, travels a distance of 28 units, right? So 5 plus 1 plus 28. That's your answer. So the total distance traveled is nothing but, let me write it down here. Total distance traveled is the first leg, which is 0 to 1. When we moved from minus 4 to 1 was 5. Then we changed direction. We traveled 1 unit, landed at the origin, and then there onwards, we don't change direction and we travel 28 units from origin to the point 28, right? So this is the total distance traveled, which is 34 units, right? So that's how we go about solving this problem. And I know folks can go wrong by just directly making a substitution S of 4 and then arriving at 28. You'll have to remember that this is not as straightforward as that, and it calls for understanding at what points we change direction. Right. Now let's come to the third part. Find the particle's acceleration each time the velocity is zero. Right. So when is the velocity becoming zero? We have already established that, right? And the velocity becomes zero at t equals 1 and t equals 2, right? So we've been asked to find what is the acceleration at these two instances, right? So how do we go about doing this? I know that my acceleration is dv by dt. What is your acceleration? Is nothing but your rate of change of velocity, right? How quickly are we accelerating? I mean, how it's nothing but the rate of change of velocity, right? And I know that my velocity is nothing but 6t square minus 18t plus 12, right? And if I use that to differentiate, what do I get? This is what I get: d by dt of 6t square minus 18t plus 12, which is nothing but so which is nothing but 12t minus 18, right? So this is my instantaneous acceleration at any point of time t, right? And we've been asked to find the acceleration at 2 points, which where the velocity becomes zero, and we know which are those 2 points. At t equals 1, my dv by dt, which is nothing but my acceleration, is 12 minus 18, which is minus 6, right? And I think when we write acceleration, the way to do that is meters, I mean units per second square. That's the And similarly, when t equals 2, we have our acceleration dv by dt equals 24 minus 18, which is your 6, right? So you can very clearly see that your instantaneous acceleration when t equals 1 is minus 6, and then t equals 2 is a plus 6, right? So there we are. Let me highlight the final answer for each of the questions. Come to question 1. We've been asked to find which are the two instances where your velocity becomes 0, which we have already highlighted, t equals 1 and 2 seconds. And then I come to the next part of the question, what is the total distance traveled, which is 34 seconds. Let me highlight that in pink as well. And I come to the final question, find my acceleration during the points when my velocity came down to 0. I'm highlighting them as well. So you have two answers for the third part, minus 6 and plus 6 units per second squared, right? So there we are. I hope you found my content useful. Please do subscribe to my channel and support. Thank you.